Hello Operations Management students. I just wanted to give you a little assistance with a couple of the assignment problems for week 3 assignment. And as you can see, I'm here in my home office and my kitty cat is right here at my side. This is Buttercup. Say hi, Buttercup. Maybe not. So this is the information given for problem 4, pennies pies, and based on this information we're going to solve the problem. So what I would do first, with the information they've given me, we need to figure out how much processing time it's going to take annually to meet the demand forecast. So I would set up a table like this. And so for example, apple pie, our demand is 60,000 pies per year. We know that our processing time is 2 minutes per pie. So if we multiply 60,000 pies per year times 2 minutes per pies, we know that it's going to take 120,000 minutes of processing time to process the apple pies. I'd want to do the same thing for cherry and pecan, and then I would want to total the minutes of all 3 pies, and that will give us the total processing time needed or capacity needed to meet our demand forecast. Once we figured out total processing time, then we need to figure out our total setup time. And again, we want to set up a little chart like this. So they gave us apple pies. Our demand is 60,000 pies per year. It says our lot size is 600 pies per lot, which is our production lot. So if we take the 60,000 pies and divide it by 600 lot size, we're going to have 100 setups during the year. So that's a manual calculation this column will have to calculate. 10 minutes per setup was given to us in the problem information. So if we multiply the 100 setups per year times 10 minutes per setup, we're going to have 1,000 minutes in setup time for the apple pie line. Now we'll want to do the same calculations for the cherry and the pecan pies. The third step is we want to determine the total operating time that we have available with our current number of shifts and our current operations. So to figure that out, we're going to take the number of days per year that we operate times the number of shifts per day times the number of hours per shift times 60 minutes per hour, and that will give us the total minutes per year that we have right now with our existing capacity. Now we're going to figure out the number of production lines we need based on what we predict our demand forecast is. So if we take the total process time required, and that's what we figured out in step 1 from this particular chart, and then we add our total setup time required, which is what we did in step 2, and it will be from this particular number. And we divide that by our total operating time available, which is what we calculated in the third step right here. Divide that and then add 1, and that will give us the number of production lines that we need. Now follow normal rounding rules. So for example, if you come to a number of 2.6, you would round that up to 3 because we can't have 2.6 production lines, so we would round that up to 3. If we came to 2.3, we would round that down to 2, and then we probably have to utilize some overtime to meet our demand forecast. So I hope that helps. For problem 5 involving new time videos, we're going to use Little's Law, which says flow equals inventory divided by throughput. So first we're going to calculate flow by inserting whatever our inventory was from the problem divided by our throughput. That will give us a number of F, and we want to convert F to hours by multiplying F times the current 8-hour shift. Once we do that, we'll look and see, is the resulting hours that we've calculated here, is it greater than the desired 6-hour goal? If the answer is yes, then we go to part B And hint, hint, the answer is yes. So in part B, we're trying to figure out what we need to increase our throughput to meet the 6-hour desired goal. And so what we want to do first is calculate the new flow time to reach that goal, which would be the desired hours, in this case 6, divided by the current shift hours, which is 8, and that will give us a new flow time of 0.75. Now that we've done that calculation in part B, we're going to plug those numbers into Little's Law formula. So F would be the 0.75 that we calculated in part B. The inventory is still 450 from the problem, and so then we're going to solve for the new throughput.